Welcome back to this episode. And in this episode, I'm going to show you how to determine the valency of an element. Now, first of all, what is a valency? We said valency are the combining powers of an element. Or we say the valency of an element is a measure of an atoms to combine with other atoms to create molecules or chemical compounds. The characteristics of an element that indicate how many more atoms can join one of its atom in a covalent bond are known as valence or valency. In chemistry, the term which was first used in 1986 is used to represent both the broad potential of combining an element and numerical value of the power of combining. Since the majority of bonds are created by the interchange of valency electrons, valency is defined as the number of electrons. The valency electron determine what valencies are and what their meaning is in chemistry. So now let's look at this example now. We have sodium, and sodium has 11 protons, which means the atomic number of sodium is 11. Now for us to know what is the valency of the sodium? One, we need to know that a valency can be 1, valency can be 2, valency can be 3, and valency can be 4. So if the number of electrons in the atomos cell exit 4, you need to subtract it from 8, because we have from group 1 to group 8. So in this case now, we want to know now what is the valency of sodium. Now sodium has 3 cells. The first cell takes 2 electrons. The second cell takes 8 electrons, and the third cell takes 1 electron. So if you add all of these things, you have 11 proton. Now, in this case now, we want to know, now we said valency. If you want to determine the valency of an element, you just go to the last cell. So here the last cell is the cell 3. And how many electrons are there? It is 1. So we say the valency of sodium, that is Na, is 1. So in that note, it also means that all the elements in group 1, they have a valency. They have a valency of what? Of 1. Because all the elements in group 1, they have 1 electron in their atomos cell. So in that case, the valency of that particular element is what? Is 1. Now let's look at another element. Let's say magnesium. Magnesium, the atomic number of magnesium is 12, which means the first cell takes 2 electrons, the second cell takes 8 electrons, and the third cell also takes 2 electrons. Now we said now, if you want to know what valency is magnesium, or what is the valency of magnesium now, you need to go to the last cell. What is the last cell? That is the third cell. The third cell is what? How many electrons are there? 2 electrons. Then we said now the valency of magnesium now is 2, which means magnesium also has a valency of 2. Hence magnesium belongs to group 2. We can also say that all the elements in group 2, they also have what? A valency of what? 2. Now let's look at another element. Let's say the element, let's say oxygen. Now oxygen, the atomic number is 8. Now oxygen has 2 cells. The first cell, that's cell 1, it has 2 electrons. The second cell has 6 electrons. So 6 plus 2 will give us 8. Now we want to know now the valency of this oxygen. But we learned earlier on that if the number of electrons in the outermost cell exceed 4, which means if it is more than 4, we have to subtract from what? From 8. Now, hence now we have here now 6 electrons in the last cell of the oxygen. We say now here 6 minus 8. Now 6 minus 8 we have minus 2. Remember, valency does not have any charge. So we are only going to take the 2, which means that the valency of oxygen is going to be what? 2. Is that? Now here now, we can able to conclude here now. We can say now, hence we are dealing with groups and valency. Now group 1, it means now all the elements in group 1, they have a valency of 1. All the elements in group 2, they have a valency of 2. All the elements in group 3, they have a valency of 3. All the elements in group 4, they have a valency of 4. Now what about 5, 6, 7, and 8? Now remember we said that valency can be 1, can be 2, can be 3, can be 4. So if the valence cell, that is the outermost cell, the last cell, if it is more than 4, we need to subtract from 8. Now it means now all the elements in group 5, they have 5 electrons in their outermost cell. So we said here now we minus it by what? By 8. Now 5 minus 8 we have 3. Which means now all the elements in group 5, they have a valency of what? 3. Again, all the elements in group 6, it means that there are 6 electrons in the outermost cell. So what do? We subtract from 8. 6 minus 8 is 2. So which means now the valency of the elements in group 6 are what? 2. Now again, elements that are in group 7, we say what do? We say we minus from 8. So 7 minus 8 we have 1. So the valency is what? Is 1. Now element in group 8, we said we minus from what? From 8. So 8 minus 8 is 0. So this one, hence their valency is 0. They don't have any valency. That's why they don't take part or they don't participate during chemical reaction. So all the elements in group 8, they are stable. Therefore, they have no valency. That is the reason why they don't participate or they don't take part in a chemical reaction. We said now valency. The same that we say is referring to the combining power of an element. Now remember we have 2 elements here. That is sulfur and oxygen, nitrogen and oxygen, nitrogen and hydrogen. So now let's look at how we are going to find or determine the valency of tetraoxosulfate 6. Now here, for you to know or to determine the valency of the compound, you need to know the central atom. What is the oxygen state of the central atom? Now here, the oxygen state here of the sulfur is 6. That is the oxygen state of sulfur here. Now oxygen is always minus 2, except in hydrogen peroxide or sodium peroxide or potassium peroxide. In their peroxide form, they have an oxygen state of minus 1. So hence it is not in its peroxide form. So we said the oxygen state of oxygen is minus 2. So minus 2 times the subscript number here is 4. So minus 2 times 4, we have minus 8. Now we combine these 2. We said 6 minus 8, we have minus 2. But we don't need the negative. So it means now the valency of this compound, that is tetraoxosulfate 6, the valency is 2. Yes. So this is what, or this is how we can find or determine the valency of a compound. Or if another way around, we can also say that we want to determine what charge does this SO4 contain. Now the charge of this SO4 is the same procedures. The oxygen state of sulfur is 6. Oxygen is minus 2 times the subscript, you have minus 8. So we said 6 minus 8, you have minus 2, which means now the charge of this entire compound is going to be what? Minus 2. So which means now the charge that the compound contains is also equal to the valency it also contains. So the charge, if the charge of a compound is minus 2, then we say now the valency of this entire compound also is going to be 2. Yes. So let's look at another one. Let's say we have NO3, that is nitrate 5. So this nitrate 5 is also the same thing. The oxygen state of the nitrogen here is 5. Oxygen is always minus 2. Minus 2 times 3, we have minus 6. So 5 minus 6, we have minus 1. So the valency is going to be 1. We don't need the negative. Now, equally again, if you want to know the charge now, we say the charge of the compound is equal to the valency it carries. Now, we want to know now the charge of this entire compound. Hence now, the oxygen state of the nitrogen is 5. Minus 2 times 3 is minus 6. So 5 minus 6 is minus 1. So you can also say that the charge of the NO3 is minus. So